Okay, I'm going to explain the components of a force. A force can be direct or a force can be oblique. A direct force is a force that acts perpendicularly or parallel to an object. If we look at this object, this force is acting parallel or it's acting perpendicular to this object. It is called a direct force. An oblique force is a force that is not parallel nor perpendicular to the object. If you look at this force, it is acting at an angle of 30 to the horizontal, the force that is pushing this object. So this force is called an oblique force. Now, the term component of a force. Components of a force are two or more forces that can replace a single force and still produce the same effect. This is a single oblique force, but this force can be replaced by two forces that will produce the same effect. Now, a force that is an oblique is the one that will be resolved into components. Let's look at the next slide. How to resolve a force into its components. Step number one, you need to identify the plane on which the forces act. Number two, you resolve the force into two components with regards to the plane. First component must be parallel, and the second component must be perpendicular. So when you resolve an oblique force, you're supposed to end with direct forces. You're going to have a force that is parallel or a force that is perpendicular to the plane. Go back to that. The component must have the same direction as the oblique force. Now, you cannot resolve a force that is pushing down and you end up with this component upward. This component must produce the same effect as this force. And the last one, use trig ratio to calculate the magnitude of the components. So Katoa will be using the trig ratios to solve the magnitude of the component. So in some questions, you can be given one of the components and the question will be calculate what is that force. Let's have a look at this example. It's a question paper of November 2017. Question paper of November 2017, you are asked to calculate the vertical and the horizontal component of the force from the diagram below. As you can see, when these forces resolve into components, it ends up with vertical and horizontal, direct, parallel, and perpendicular. So you identify the plane at which the force is acting. So you are only given this line from this point to that point. And the angle it makes with the horizontal, this is the horizontal line. So it's acting on this plane. It's 20 degrees. So you close the direction, you close this triangle. You replace this with component. Let's have a look at this. The force, the value, the magnitude of the force is 50 and the angle is 20. The magnitude of the force is 50 Newton. And the angle from the horizontal is 20 degrees. To apply the last step says to use so, ka, tower, the trig ratios. So when closing this triangle, you have horizontal direction and you close it to that point. You put the arrows. So these forces on the first quadrant, both X and Y are positive. So this means these two components will be both positive. This one is the horizontal component, and this one is the vertical component. I'll use VC and HC. Now, when you use the trig ratio, you only have this force. This force now is the hypotenuse. This is X, Y, and hypotenuse. Now, a trig ratio that fits in order to calculate the VC. This is opposite side over hypotenuse. Opposite and hypotenuse. So this will take sine 20 equal to the opposite side is VC and the hypotenuse is 50. Now, when you cross multiply, this will be VC times 1, which is VC, equal to 50 multiplied by sine of 20. Then you use your calculator to get what is 50 sine of 20. And the answer is 17,101. So this forces in newtons. This component will also be in newtons. The second component, which is the HC, we always use the givens. If the question does not specify, you can still use Pythagoras theorem to get the missing side when you already have R and Y. You can solve for X. But it is wise to use the givens, just in case this answer is incorrect. Maybe the calculator is not in degrees. This is adjacent side over hypotenuse. Adjacent and hypotenuse is the cos of theta. So it will be cos of 20 equal to adjacent side is horizontal component and the hypotenuse is 50. So when you make HC the subject, this will be HC times 1 equal to 50 times cos of 20. And you use a calculator to get what is 50 cos of 20. And the answer is 46,984. 985 newtons. That will be the answer. Now, this component HC, the horizontal one, since it is using cos, it is called FC. And the vertical component, since it uses sine, it will be also called Fs for sine theta. This is Fc for cos of theta. Now, let me generalize this equation. When you are given a force of F at an angle of theta, it will have this component and this component. This component is FC, and the vertical one is Fs. Now, the Fs, if you look at this equation, where there is 50, now we have F. So it means it will be F sine, there is sine. Where there is 20 there, we have theta now. And FC, where there is 50, is this F. So it will be F cos, where there is 20, there is theta. So these are the two components. If this angle is measured from the horizontal. Now this will be the direction of the component if this angle lies on the first quadrant. Both components will be positive. But if this 50 lies on the second quadrant, you're given the angle of 20 here. Okay, let's say it's exam, and this angle is given as 160 degrees. This one is not given. So to close a triangle, SOHCAHTOA or the trig ratio only apply to a right angled triangle. So you cannot close here. This won't be a right angled triangle. You are going to close this side. So not all the cases, the angle will be obvious. So if you are given 160, the straight line is 180 and you subtract 160, then you get this angle as 20. This component is horizontal, so it will be FC. This one is vertical, it will be FS. And this will be F, the given force. Now, this is second quadrant. On the second quadrant, X is negative. So the FC will be equal to minus, formula of FC is F cos theta. So it will be minus F cos of theta. But Fs will be equal to Y is positive on the second quadrant. Y is positive on the second quadrant. So the Fs will be positive F sine of theta. Now, if this force lies on the third quadrant, let's say you are given this force like this, and this angle is 20 or theta. You close the right angle triangle like that. That is third quadrant. Third quadrant, FC, X and Y, both X and Y are negative. So FC will be negative as well as Fs will be negative. If the force lies on the fourth quadrant, you're given a force like this. This is fourth quadrant. This is F, and it makes this angle with the horizontal angle theta. You close your triangle like this. This is Fs, and this is Fc. This will be the F, which is your hypotenuse. Fourth quadrant, X is positive and Y is negative. So it means Fs will be negative and Fc will be positive, the X component. This is X-axis, Y-axis, X, Y, X, Y, X, Y, and so on. Now, not all the questions will be looking for the components. In some questions, you can be given the component and asked to calculate that force, the applied force. For example, let's look at this question paper. This is the question paper of November 2013. The question paper where you are only given the components and you are asked to calculate the force, November 2013. An unknown force is inclined at angle 22 to the horizontal. The vertical component of the unknown force is 75. Determine the value of the unknown force. So the angles, positive angles. If you have a protractor, you measure the angle from this direction going this way. So 22 degrees to the horizontal. That force is inclined at that angle. Now you need to identify the plane on which the force is acting. To answer this question of this unknown force, you can have a force here that is inclined at 22 degrees to the horizontal. This is the force, and the angle is 22 degrees. The vertical component of the unknown force is 75. So if you close it this way, Fs is given as 75 Newton, vertical component. You are not given the force, but you are given the component. But Fc is not given. Now the question says, determine the value of the unknown force. We use saw, car, tower. Now, whatever ratio you're going to use, it has to include this side and this side. So this is opposite over hypotenuse. Opposite over hypotenuse is sine. So you say sine of 22 degrees is equal to, opposite side is 75. This is opposite to the angle, and hypotenuse is F. You cross multiply this F sine of 22 will be equal to 75. You divide both sides by sine of 22, both sides by sine of 22. Cancel out, and this force will be equal to 75 divided by sine of 22 degrees. And the answer is 200.21. So in some question, a question can say, use tan theta. Let's say if you are given, you want to calculate the FC, and the question says use tan theta. This will be opposite over adjacent. That will be tan theta. It will be 10 of 22 equal to the opposite side is Fs, which is 75, divided by Fc. And you cross multiply. This will be Fc 10 of 22 equal to 75. Now to make Fc the subject, you divide both sides by 10 of 22, 10 of 22. Fc is the horizontal component. Then this Fc will be equal to 75 divided by 10 of 22. (75 divided by 10/22), and the answer will be 185,632. Now, this component and this component, this is Fs and this is Fc. They can give us this value of 200 when added together. By using Pythagoras theorem. When using Pythagoras theorem, this is x and y, and this is the hypotenuse. So F will be, I'm just proving it. F will be equal to square root of 75 squared plus 185,632 squared. And the answer will be, it has to be under square root, Pythagoras theorem. So this will be 75 squared plus 185,632 squared. And the answer is 200,21 Newton. Components, they replace this and produce the same effect. Also, resultant is a single force that replaces these two and produce the same effect. Thank you.